एवरीवन, हम स्टार्ट करते हैं यूनिट 3 काइनेटिक थ्योरी ऑफ गैसेस। इसमें सबसे पहले डिस्कस करते हैं काइनेटिक मॉडल। काइनेटिक मॉडल ऑफ द गैसेस एक्सप्लेन द टू मोस्ट इम्पॉर्टेंट एरियाज। पहला है द फ्लो और ट्रांसफर ऑफ हीट, सेकेंड द रिलेशन बिटवीन टेम्परेचर, प्रेशर एंड वॉल्यूम, प्रॉपर्टीज ऑफ गैसेस। The theory take into account the microscopic structure which state that any gas is composed of a large number of small particles, individual atom or molecule that are in constant motion. आगे बढ़ते हैं, देखते हैं अब postulates of kinetic theory of gases. पहला postulates, all gases are composed of molecule and molecule of a gases are hard, smooth, spherical particle. यानी कि सभी गैसेस जो होती हैं वो मॉलिक्यूल से मिलकर बनी होती हैं। और मॉलिक्यूल जो है वो कैसा हो सकता है, हार्ड भी हो सकता है, स्मूथ हो सकता है, स्फेरिकल पार्टिकल। दूसरा है द मूविंग, द मॉलिक्यूल्स आर लाइक पॉइंट मासेस बिकॉज दे आर एक्सट्रीमली स्मॉल। यानी मॉलिक्यूल्स जो होते हैं वो पॉइंट मास की तरह होते हैं। तीसरा द मॉलिक्यूल आर in constantly random motion and they have different velocity and their velocity increases with temperature. ये मॉलिक्यूल जो है कंटिन्यूसली जो है मोशन कर रहे होते हैं, रैंडम मोशन, जिगजैग मोशन, अलग अलग वेलोसिटी से, और इनकी वेलोसिटी जो है वो टेम्परेचर के साथ बढ़ रही होती है। फोर्थ पॉइंट इज दे डू नॉट एक्सर्ट एनी फोर्स अपॉन ईच अदर एक्सेप्ट एट द कोलिजन इंस्टेंट। ये एक दूसरे पे कोई भी फोर्स एग्जर्ट नहीं करते हैं जब तक कि कोई कोलिजन ना हो। फिफ्थ पॉइंट द टाइम ड्यूरिंग कोलिजन टेक प्लेस इज नेग्लिजिबल एज कंपेयर टू टाइम बिटवीन टू सक्सेसिव कोलिजन। यानी कि जो है इनके बीच जो है लगभग कोलिजन की टाइम जो है नेग्लिजिबल होता है ड्यूरिंग कोलिजन की अगर बात करें तो। सिक्स पॉइंट ऑल द कोलिजन आर परफेक्टली इलास्टिक इन नेचर। सभी कोलिजन जो होते हैं वो पूरी तरह इलास्टिक होते हैं। सेवेंथ पॉइंट इज द नंबर ऑफ मॉलिक्यूल्स पर यूनिट वॉल्यूम ऑफ द गैस इज वेरी लार्ज एंड रिमेन्स कांस्टेंट। यानी नंबर ऑफ मॉलिक्यूल पर यूनिट वॉल्यूम जो है गैस का बहुत ज़्यादा होता है और लगभग कांस्टेंट रहता है। नेक्स्ट पॉइंट इज द मॉलिक्यूल ऑफ आइडियल गैस ओबेज न्यूटन। तो आगे देखते हैं इसमें बॉयल्स लॉ। व्हेन द टेम्परेचर ऑफ गैस इज कांस्टेंट देन प्रेशर इज इनवर्सली प्रोपोर्शनल टू द वॉल्यूम ऑफ गैस गिवन मास ऑफ गैस। इट मीन्स P is inversely proportional to 1/V or PV is equal to constant. Second law is Charles law. According to this law, volume of a given mass of a gas at constant pressure is directly proportional to the absolute temperature. It means V is directly proportional to T. Third law is Gay-Lussac law. According to this law, pressure of a given mass of an ideal gas is directly proportional to its absolute temperature. The volume of the gas remains constant. Means P is डायरेक्टली प्रोपोर्शनल टू T। आगे बढ़ते हैं, देखते हैं अवोगाद्रो लॉ। अकॉर्डिंग टू दिस लॉ इक्वल वॉल्यूम ऑफ ऑल गैसेस अंडर आइडेंटिकल और सेम कंडीशन ऑफ टेम्परेचर एंड प्रेशर कंटेन द सेम नंबर ऑफ मॉलिक्यूल। नेक्स्ट लॉ इज ग्राम्स लॉ ऑफ डिफ्यूजन। अकॉर्डिंग टू दिस लॉ रेट ऑफ डिफ्यूजन ऑफ टू गैसेस आर inversely proportional to the square root of their densities. It means R is inversely proportional to 1/root of rho, where rho is the density of gas. Next law is Dalton's law of partial pressure. According to this law, total pressure exerted by a mixture of gas which do not interact with each other is equal to the sum of partial pressure. It means P is equal to P1 plus P2 plus P3 dot dot dot. Next topic is root mean square speed. Root mean square speed is directly proportional to square root of temperature and inversely proportional to square root of mass of molecule. It means Vrms is equal to root 3 RT by capital M. Now next is mean speed or average speed. It is the average speed with which a molecule of the gas moves. V average is equal to root of 8 RT upon pi capital M. Now next is most probable speed. Most probable speed of the molecule of a gas is the speed which is processed by maximum fraction of total number of molecule of the gas. The formula of most probable speed V MP is equal to root RT upon capital M, in which most probable speed is less than average speed and average speed is less than root mean speed. Now next topic is degree of freedom. The total number of independent variables needed to describe the state of motion completely are said to be degree of freedom. Example: if an ant moving in a straight line has 1 degree of freedom. If this motion in a plane, then it has 2 degree of freedom with coordinate x and y. If a bird is flying in air, then it has 3 degree of freedom with coordinate x, y, z. Degree of freedom for monoatomic, diatomic and triatomic molecule. First, monoatomic molecule. A monoatomic molecule like as helium, neon, argon has 3 degree of freedom due to its translatory motion along x, y and z axis. Now next topic is diatomic molecule. A diatomic molecule having a dumbbell shape like structure as hydro S2, N2, O2, etc. has 5 degree of freedom, 3 translational plus 2 rotational. Now next is triatomic molecule. Triatomic molecule are molecules composed of 3 atoms if it is non-linear like as S2S, CO2, etc. They have 6 degree of freedom, 3 translational plus 3 rotational. If a triatomic molecule is linear like CO2, CH2, etc., then it have 5 degree of freedom, 3 translational plus 2 rotational. At high temperature, molecule can also possess vibratory motion, show vibrational degree of freedom generated. Now next law is law of equipartition of energy. According to this law, the average energy per degree of freedom of any classical body is an number of system of such object in thermal equilibrium at temperature T is half kT. Now next is relation between Cp, Cv and degree of freedom. Cp is equal to F by 2 into R, where F is degree of freedom. Cp is equal to R in bracket F by 2 plus 1. Cp by Cv is equal to 1 plus 2 by F. For the case of monoatomic gases, F is equal to 3, then Cv is equal to 3 by 2R and Cp is equal to 5 by 2R, and the ratio of Cp by Cv gamma is equal to 1.66 for monoatomic gases. For diatomic gases, where degree of freedom is 5, 3 translational plus 2 rotational, then the value of Cv is 5 by 2R, the value of Cp is 7 by 2R, the value of gamma, it means ratio of Cp upon Cv, is 1.40 for diatomic gases. Now next is triatomic gases. For triatomic gases, degree of freedom is 6, 3 translational plus 3 rotational. Then Cb is equal to 3R, Cp is equal to 4R, and the ratio of Cp by Cb gamma is equal to 1.33 for triatomic gases. Now next, critical constant of a gas. First one is critical temperature. It is the highest temperature of a gas at which the gas can be liquefied by pressure, but above which no liquefaction is possible. However, greater the pressure. Now the formula of critical temperature Tc is equal to 8A upon 27 Rb. Next is critical pressure. The pressure needed to liquefy a gas at its critical temperature is called the critical pressure. Critical pressure Pc is equal to 8 upon 27 B square. Now critical volume. The volume occupied by 1 gram of gas at the critical temperature and critical pressure is called critical volume. The formula of critical volume Vc is equal to 3V. Now next is Maxwell's distribution law of velocity. Maxwell made the following assumption for distribution of velocity among the molecule of the gas. First one is, in steady state, density of molecule remains uniform throughout the gas. Second one is, the gas molecule can possess all possible velocity between 0 to infinity. Third is, though the velocity of individual molecule are changing, but definite number of molecules have velocity between different range. Fourth is, the fraction of molecules with very low or high velocity is very small. Fifth point is, the fraction of molecule possessing high velocity gas and increasing till it reaches the peak and further it start decreasing.